Exam 2 is coming up, so we have to take a look at chapter 7. We know that 7.1 is the review of basic integration. And there are really no questions that are directly asked for 7.1, but remember that when you do partial fraction decomposition, you will get maybe ln u sub kind of deal. So that actually falls under that. Any of those techniques end up with u sub. U sub is within the basic, right, review from the previous calc course. 7.2 is by parts. You must have 1 or 2 questions here. Well, integration by parts, it's usually like ln over x squared, or x squared times sine x, or x squared times e to the x, or if I'm really annoyed, e to the x times sine x, right? You saw a lot of those, right? You have my notes. Notes have been re-uploaded, so I hope that all worked out. And all right, great. So please go and review those. And then there are 5,000 different examples given on YouTube on integration by parts. Obviously, the problems will be similar to what you have in a textbook and homework, so something in that area. So 1 or 2 questions there. 7.3 is trig integrals. Now, I will put 0 or 1. And the reason is 0 or 1 is because the next section, 7.4, is trig substitution. And you will definitely have 1 question there. Now, every trig, well, I'm hearing requests for 2, but so 1 or 2, or no, 1? The trig integral questions, guys, are the ones where you have to solve a trigonometric integral at the end, right? So, oh, text Jessica that I'm still in class, because she might come. Yeah. What else? So trig sub question will necessarily end in you working out trig integral. So that's why there is no reason for me to put 2 separate questions, right? Now here we go with 7.5, which is partial fractions. I am inclined to put 2 questions. Now hold your oohs and ahs, because I still haven't explained that. 1 question is usually short calculation 1, where you have maybe A and B, or maybe A, B, C, which is easy to solve. And then the other question is insanity of variables, but you're only supposed to set it up. So 1 question will display your ability to grind through partial fraction decomposition procedure on a simple, shorter problem. And the other one will test your ability to set up more complicated problems, which you would hopefully plug into Mathematica and get the answer on the other end. So that's why partial fractions should be about 2 problems. 7.6 we're skipping because I can't really give you the chart of all the integrals, because they cover all the other integrals as well. And in that respect, you still owe the homework for that section, because you have the chart with you at all times in the book, and you also have Mathematica. But it's not going to be a question, use the tables to solve that. Now we have 7.7, which is numerics, numerical integration. You have 3 methods. You have midpoint, trapezoid, and Simpsons. Inclined to put 2 one or two, depends on how it works, one or two problems. Seven, eight, improper. One or two, because we have type 1, type 2, right? Seven, 9 differential equations. One problem. Generally, you separate the variables, or the first order linear where you memorize the formula, right? Which is, but you can still do it with the separation of variables. So that's it. We technically have 7 sections, which is 7 problems, and then 3 problems will be repeats from this where you have or 2. That's the exam. So for by parts, you are looking into x times e to the x squared times e to the x times sine x times, right? So that kind of stuff, or sine 2x, sine 3x, whatever. Trig integrals, if it's there, if it's anything there, you must know obviously the power reducing formula. That's extremely important, power reducing formula for sine and cosine. So go from x sine squared and cosine squared down to 1 plus minus cosine 2x over 2. And then u substitution is big within that section. So making sure that you are using correct u and b. Trig sub. I say one question. That's my favorite out of all sections because it displays the most of the knowledge, I think, because it's trig and it's integration and it's substitution and it's derivatives, deriving trig from triangle and so on. By far my favorite stuff in chapter 7. One question there because it's really long and involved and so on. If it's up to me, it would just be 10 questions of that when we're done. It covers a lot, but it's not. Partial fraction decomposition, I already went over that, so it's something that is shorter. Maybe 2 variables, maybe 3 variables if the system is nice enough to be solved. And then numerics, you have to be careful about Simpson's rule, right? Because if I troll you with a question, solve the Simpson's rule using n equals to 5, and and you do it, it's going to be wrong because you can't have, right? The n must be even for Simpson's rule. So you have to have n equals to 2, 4, 6, or 8. Can't have n equals to 5. That could save you some time, right, if I do that. Obviously, for trapezoid and midpoint, you can have any number of rectangles. That's technically a free question, so take a look at that. Now, improper integrals. Guys, that can propagate through every problem as long as there are limits, right? I can have a question that it's by parts with limits, and then there is the asymptote, right? Or one of the limits is infinity. It could be trig sub, it could be partial fraction decomposition, it could be any one of those. So it is your job to, no matter what calculus integral you see that has limits, the first thing is you make sure that it's not improper. Obviously, if you see infinity, clearly it's improper. But if you see going from 2 to 4, just make sure that there are no vertical asymptotes between 2 and 4. Because if they are, I don't care that you have to do integration by parts. You must first make the integrals and do the limit and all of that stuff, and then go with your by parts and stuff like that. So that's something that is very, very important. So the clear example of that, I'm giving you this example because, so here I'll do it in red. Put these guys. So if I have, let's say, ln x over x dx, this is Oh, wait, this is U sub. It's U sub, right? If I go from 0 to infinity, if I go from 0 to 3, you see that? ln x cannot be computed at 0. X in denominator computed at 0, right? There is asymptote. There is a fat asymptote there because both of these don't work at 0, which means your next step is immediately limit a goes to 0 and then a to 3 and then ln x over x dx, and then if you know your u sub, you will actually do that problem. So this integral covers two sections, 7.1, which is actually 5.5, u sub, right? And then also improper. And you can have this with any, right? We said improper integrals are not a new method of integration. Improper integrals bring on these limits in the game so that we can see if the area which was leaking, whether horizontally due to infinity or vertically due to asymptotic interruption, whether that area now converges or diverges. And that's what we did and explored. So every single problem that shows up on the test with limits, the first order of business is to check if it's improper integral. That means any of the two endpoints that are given, any of the two limits, could be vertical asymptotes. If they are, well, then it's an easy setup like this one, because 0 was that bad point, right? So we had limit change that one. And then on the other side, but you know what? It could be somewhere in the middle, right? It could be somewhere in the middle. I can have a partial fraction decomposition problem with limits, and you go partial fraction decomposition, and you do it, and you get answer to be 7, and then it's wrong because it diverges, right? Because you didn't check, right? So here is another, let's say, 1 over x times x minus 3 dx. And everyone goes, that's the cheap partial fraction decomposition. I'm going to do this in 63 seconds, right? Oh, I didn't put the limits there. 1 to 5. 1 to 5. So, what's the problem here? 3 is the problem. 3 is where the vertical asymptote is, and because the vertical asymptote is at 3, we have to have integral 1 to 3 plus integral 3 to 5, and then eventually you have limit b goes to 3, integral 1 to b, plus the limit b goes to, a goes to now 3, a to 5. The guts of the integral will still be partial fraction decomposition. You have to do it only once because it's identical integral. But you have to apply the limit at the end. So every single problem, and it's not just for Calc 1, this goes for Calc 3, it goes for Calc 3 for differential equations and every other course following. As soon as you see a definite integral, the first thing you must check is this type of discontinuity. Right? Is there a vertical asymptote in the range? In the interval for your integration? And if it is, it's improper right there. Integration technique on the side. You do that. So that's that. And then, as I said, differential equations at the end. You're looking into separation of variables is the only thing we did, and you compute the problem. Whether it's going to be initial condition or not, that depends on the length of the other problems and so on. We'll try to keep the exam, shorter than 3 hours. So, just kidding. Again, about 10 problems. Depending on their length, it tends to be, lengthier exam. And exam is on Tuesday, right? Mm-hmm. So, we'll probably spend about hour 40 on the test or so because you have to check it. This is the lengthiest test probably of your math career. You know how lab worked out, right? Lab 2 plus lab 3, that's your exam 2. So It's going to take longer time to solve it. And then after that, we're going to have break after the test, and then we'll cover 8.4. So we can finish this chapter 8.5 and 8.6 next week. And next week, chapter 8 will be done. And the following week, we are going to do chapter 9. The next week, we do review, test, and start chapter 10. We have 3 sections in chapter 10. Cover that. We have comfortable time to finish the whole thing. It's just, right? We have to, and then we at some point we also have to have the test on sections, on chapters 8 and 9. That's one test. So 10 sections there. Yes?
Chapter 10 million the final, right?
Yes, and the entire Calc 3. How many of you are taking Calc 3? Yeah, so chapter 10, I mean, there is really no reason to sign up if you don't know chapter 10, because today people were screaming, right, with the polar coordinates. So we did polar integration today, and whoever doesn't remember it from Calc 2, chapter 10, it's going to be hours and hours of YouTube to review that so that we can upgrade it now, and we're going to have even nastier upgrade later for cylindrical and spherical. 3D triple integrals for that. It's extremely easy if you have the base for it. Extremely easy if you have base for it. Matt is just beasting through it. It's like whistling along the way. He's like, but then he learned chapter 10, so he doesn't care, right? But then there is some that experience the burning already. So, guys, I'll see you all. You have your SI session now. You can work out some examples. I hope that you all obviously stay. Do you take attendance every time? Okay, good, because that's mandatory. Work out on the examples. Try to solve as many as you can of those lab questions. To have those labs handed in as soon as possible. I didn't say any dates. I mean, lab 2 would be good at the day of the exam, but then lab 3, like next class, you can. So that you can do lab 4 and 5. Yes. Yeah, thank you. It's on my desk in the office. I'm gonna run and get that. Okay, we're stopping the stream because this is done, and then we'll do the rest.